Hello and good evening. Tonight we are going to do something else than we usually do, in that we are still going to do live coding, but this time I'll be just grinding Leetcodes, and I think this may be popular with some of my viewers, and the reason is that I may be preparing for a FAANG interview, and I'm pretty sure there is going to be Leetcodes. So stay tuned, and if I'm really going to apply for a FAANG company, I'm definitely going to be doing more of these. And yep, let me know if there is any particular question you want covered. And in the meantime, I'm going to start with a question I read about today on, I think it was Facebook or Twitter. Basically, somebody was complaining that they were unable to do the relatively simple question of what was it? The relatively simple question of rotate an array, and yes, I have actually purchased Leetcode Premium, and therefore I'm actually have access to premium content, and I may or may not use it. And there are also these editorials, and these editorials actually usually provide pretty good explanations of problems, so I'm planning to read those if they are available free of charge. And if they're not available free of charge, I don't want to do it because I don't want to get into trouble with Leetcode's lawyers. And in the meantime, I'll just start with this rotate array question. And I'm going to be doing all of my solutions in Go. And yep, so this question, I believe it is simple. It may not be as simple as I believe. And the idea is to move the array k steps to the right and put the content from the right hand side of the array on the left hand side of the array. And yep, there are several ways to do it, and apparently this question has appeared at Amazon, Google, and Apple. So yep, let's see. Yes, so one way I can think of when doing it in place would be basically taking the last element of the array, storing it in a variable, then moving everything to the right, and then putting the element on the I took from the end and the beginning. And I'm going to do it k times. So let me see. I'm going to use range k because since Go I think 1.22 it is possible to iterate over integers. And yes, last element is going to equal nums length of nums minus 1, because this is the last index. And also I'm going to enable the mappings, and I believe you may want dark mode. Okay, anyway, I don't mind those. I don't mind white mode. Okay. So the first thing I did was take the last element of the array, and then I'm going to iterate from the end of the array until the beginning of the array. So for I equals length of numbers -2, I is greater than 0, I minus minus. I'm going to say numbers I plus 1 equals numbers of I, and then numbers 0 equals last, and then I return nums. No new variables. Okay. Too many return values. Okay, like this. Okay, it seems that I don't actually need to iterate over all of these. I just need to I'm going to use the variable called iteration for this. Let me see. Iteration. Okay, I don't know why this is happening. Okay, so it seems like I found a solution. And apparently it works for most questions, but not with such a big array. And this means I need to find a better solution. So I think what I'm going to do is I'm going to clone everything at the end of the array. So equals append and that will be yeah, I need to check the slicing syntax. That would be the last k elements of the array. That would be nums so let me think. That would be the length of nums minus k and copy it like this. Then okay, I have a copy of the final numbers. Then now I need to move everything starting from that that last element. Okay, so that would mean for I equals length of nums minus k minus 1, I is greater than 0, I plus plus, numbers of I plus k equals nums plus I, and then for I element in the range of final numbers, numbers I equals element. Then let me see. Okay, last declared and not used. Okay, it seems to work. I'm going to submit now. Slice bounds out of range. Oh. Okay, k is not negative, but they never said it's greater than the length of numbers. So but we can say that if k is greater than length of numbers, k equals k divided by the length of numbers. Let's see. Okay. So apparently this has worked. And yep, this is one solution I can think of. And yep, to those who haven't seen it yet, the idea is that if k is greater than the length of numbers, then you don't need to iterate over the whole array so many times, because it's just going to be repeating itself. So for example, if the length of the array is if the length of the array is 1 and k is 2, then we basically don't need to do anything. Okay, let me analyze complexity. Okay, it says my time complexity is O of n. Okay, this was the first question we did today, 189, and I'm going to add it. I'm going to add it in the description. And it was more difficult than I thought. Yeah. Shift all the elements around it. Yeah, I can think of another solution. I don't know if it makes sense. Basically, if we could try moving the Okay, my idea is that maybe I'll try to do this solution with without allocating additional space, and for example, if okay, maybe that first solution wasn't so stupid. It's just that I'm going to take okay, I'll be going backwards. So for I equals length of numbers -1, I is greater or equal to 0, I minus minus. So I'm going for every element of the array. The buffer would be buffer would be the number at I. Let's see if this works. I can imagine it not working, and that would be a shame. Okay, and the place we're going to replace would be okay, A and B would be numbers of I, and numbers of numbers k minus. Okay, so for example, the last element, take the last 3 elements. Okay, maybe like this. We know that with k equals 2, then if k equals 2, then the every element in this array, so then numbers of k, element k in the array Okay, I think I'm going to read the editorial. Okay, so what you see here is the explanation. We can directly place every number of the array at its required correct position, but if we do that, we will destroy the original element, thus we need to store the number being replaced in a temporary variable. When we can place the replaced number temp at its correct position and so on, n times, where n is the length of array. We have chosen n to be the number of replacements since we have to shift all the elements of the array, which is n. But there could be a problem with this method if n the count number stipulates that we will eventually reach the number from which we eventually started. Suppose we have n as the number of elements in the array and k is the number of shifts required. Furthermore, assume. What does this mean? Okay. Hello my viewers. I don't believe Leetcode is a good way to start programming, and actually I think it's better to learn a programming language first. And yeah, Leetcodes are not really relevant to actual work. They are more like they're designed to check your knowledge of algorithms and data structures, and therefore they are used at companies to filter out people who do not have studied enough algorithms and data structures. Oh yes, the language C is... It's a good first language, but do not expect to get good at it. At least not very soon. Yes, CS50 is great, but it's also very difficult if you haven't had any experience with programming first. When we start placing all elements at their correct position in the first cycle, we hit all. When we reach back the original index we have placed, look at the following. Okay, so I haven't really solved too many. I actually hate Leetcodes, and I'm only doing this because I actually want to apply at a FAANG company. And I wouldn't be doing it on stream if I was any good. I just want to have some company. And this question is much more difficult than I thought. What on earth is this? Yes, so to those of you who weren't watching when I was here, I actually did on my own this solution with an additional array, and it wasn't too bad. It's the solution with constant space that is actually looks like a pain in the neck, because it feels like it should be easy, but it's not. So what in the heck is this doing? Okay, if k equals k modulo length of numbers, start is 0, count is 0. Okay. For count is size equals length of numbers, k equals k modulo size for count until count is smaller than size. Current equals start, previous equals numbers at start. Okay. For if start is different than current break, start plus plus. Next equals current plus k modulo size, temp equals numbers next, numbers next equals previous, previous equals temp, current equals next, count plus plus. Okay, not gonna lie, I don't know how this works, but let's see. Okay, it also looks like I implemented it incorrectly. While count is less than size. Current equals start. Previous equals numbers at start. So this is a do while, and there are no do while loops in Go. So I'm doing if start equals current break. So I actually want while start equals does not equal current break. Okay. And let's submit. Okay. So this did got this did work, but I have no idea how. I'm just going to do a debug println next current count. Let's see. So first we are I'm going to put it here. Okay, so it looks like the first thing we do is we move temp okay, the previous variable this is so complicated, and I can understand why this someone who wrote it about it on Twitter or wherever it was actually pretty disheartened by this solution, because let me tell you, the first thing we do is we move from temp is good. The first number we move is the number 4, which is at index 3. So we are taking the number 4 from index 3 and we first what the heck? Mr. Okay, first current is 0. K is 3. So next will be 3 because it's current plus K divided remainder by size. So next is going to equal 3. Then we take the number at index 3, which is 4, and at index 4 we put the number from index 0, which was the previous one we did. Yes, previous was number at 0, and now in the variable previous we put the variable temp, and then current is going to be next. So next becomes 3. We did 1. Okay. If we notice that we have made a circle so that start equals current, we stop this madness and start. Okay, so I think I kind of see it. So we're going to move from 3 to 0. No, we're going to move the number from 0 to number 3, and then the next you're moving from 0 to 3, then from 6 to 3, and then from index 6 to 3, then okay, we probably should care more about start. So this would be next current. Let me see. So apparently we never exit this loop. We never had to exit this loop because we are just running around in circles. So we're moving from 3 to 0, from 6 to 3, then from 2 to 6, then from 5 to 2, then from 1 to 5, then from 4 to 1, then from 0 to 4. And it seems like we can do it in basically in how on earth does this work? We are okay, so okay, k is 3. 0, we start from 0, we do 0 plus 3, which is k is 3, n is 7. We start from 0, 0 plus 3 is 3, 3 plus 3 is 6, then 6 plus 3 is 9, which goes to 2, then we do 2 plus 3 is 5, then 5 plus 3 is 8, which becomes 1, 1 plus 3 is 4, then 4, okay. This kind of makes sense because we are doing rounds like this. Yes, hello my dear viewers. You are not going to see a lot of interesting content here because it's just me doing a single Leetcode question for now and trying to understand how it works. And I do understand the solution, but oh man, it is difficult to understand. And I wouldn't be able to come up with it if I didn't learn it. Yep. So I'm going to try a different question. And just as a reminder, my first accepted solution was with one additional array. And in this array, I copied the last k elements from the array into a separate slice, and then removed everything by k elements, and then I appended the elements at the beginning of the slice. Yes, that was my first submission, and the second submission was this one. And I did not come up with this solution on my own. It was bestowed on me by the gods of Leetcode. And I think I'm going to do something easy now. Rotate string. Given two strings s and goal. Okay. Okay, the first thing, if length of s is different than length of goal, return false, return true. This is the most basic. Okay, so in case 1, okay. I'm going to look at hints. Okay, I'm going to try the most brutal solution, which means I'm going to just try rotating until it works. So for I in range of s okay. going to take the first element, new last equals string based on last one and is 1, I is smaller than length of runs, I plus plus attempt equals append string append runs I runs if attempt equals go, return true, return false. Expected runs. Okay. Okay, so my first attempt will be an empty array of runs. String runs I plus string runs until I 0 to I. If attempt equals go, return true. Okay, let's see. Now submit. Wrong answer. Okay, so apparently this is one solution. If first we check if the length is different. If the length is different, then it's definitely not going to be possible. Then we slice the string into a run slice, and if then for 0 until the length of runes basically we take the last, we slice the array from the ith element to the end, and then from 0 to I. If we got the desired string, it means that the length is possible. This is possible. Let me see, analyze complexity. Okay. What on earth is this? Yes, so I did one attempt and it was accepted. There are at least two insanely complex algorithms that I don't even... I mean, I would be implementing this if I wanted extremely high performance. Yeah, so I need a break. I'll be back in a moment. And yes. Yep. Yes, hello back. Yes, so this question is solved. We got an accepted solution. I'm not very happy with my solution because it's really not very elegant. But maybe I should just try once again to see if I can do it better. If length of s equals 0, return true. Yes, these are the two approaches. And then I will go for k. K will be the number of permutations, just like we. So basically what I'm going to do is I'm going to see if I can, if all the elements of the array are exactly the elements of, if all the characters in the string are the exact same elements of a string as something else. Let's see. For I char in range of S and other char equals goal I plus k divided by size equals length of S divided by size if other char is different from this char, continue outer, return true. Okay, there is no runes, there is length of S, byte and a rune. Let's see. Okay, so apparently this worked, and I'm trying. What I'm doing here is I have an outer loop where I'm trying the number of permutations. So for example, the first thing I'm going to do is I'm trying with 0, with a shift of 0, and then for every character in this in the first string, I'm checking if the corresponding character moved by k is the same, and if it's not, then I just try with another permutation with another number of k, and I'm using continue other, and this means that I skip. Actually, I could have just, yeah, I cannot use break here, because if I use break, it would go to return true, and this return true is supposed to only be executed if all of the iterations in the inner loop were correct. So we are using continue outer, and I think we could also break continue outer or break outer, and if it failed for every number for every k, it means we return false. Okay. This wasn't easy. I'm not very happy about it. I'm just going to use all easy. What's Candy Crush? Shit. Okay, this is shit. Oh. Okay, this looks like it could be a lot of fun, and also looks like it could be very difficult, and actually it looks like something I want to implement in real life. We have a board of what does this premium mean here? It's a premium question. What's the hint? Okay, this makes sense. Perform the crush and gravity steps. Okay, I don't think I can solve it today. It looks very complex. Huh. Maybe I need to check all neighbors. So okay, I'm m is greater than 3 and n is smaller than 50. Okay. Okay, so m equals length of board, n equals length of board of the first row of the board. Okay, so I'm going to try the crash step. So I'm going to iterate over every field in the on this board. So for x equals range outer, for x equals range yeah, I just got a comment in a private message saying that there are some hints in here, and yes, I actually already read the hint. There are crash and gravity steps, and I'm starting with the crash step, and the crash step basically involves going over the whole table, over the whole board, and checking all neighbors, and if there is I think I only need to check neighbors to the right and down. It's enough. So so for x equals a range of m is the number of rows. Yes. Okay, I'm going to start with y. So y is the range of m. Okay, so that would be rows, and then for x equals range of n, and the value equals board at the y and x if value equals 0, continue, because we don't have to do anything if it's empty. So if this field is empty, go to next. So then okay, so I could actually just say for y row equals range of board, and for x cell equals range row, and this means that if cell equals 0, we continue. Then then I would say we search down and right. So you can search for neighbors in the Yes, and I'm also going to define a type for a coordinate, and that would be, there are no tuples in Go, but I can do I can just define an integer array, and that would be to crush equals make slice of coordinate and the size of 0. Yes, so the next thing we're going to do is we're going to search for neighbors to the right. I would say we could try and look ahead. So previous cell equals cell, and okay, I would say nay 0. So yes, so if a cell equals 0, continue. And if cell is different from the previous cell, continue. If cell equals 0 or is different from previous cell, continue. And if cell is different from a previous cell, let's say row neighbor count. Previous column equals 0, row neighbor count. Column count is 0, row count is 0. Okay, so if cell is 0 or cell is different from a previous cell, continue. If cell is equal to previous column count plus plus previous row equals if y is greater than 0, previous row equals board y minus 1 of x if previous row is the same as cell, it means that the row count goes +1. So if we go in rows and columns, and first I see if the previous cell was this previous cell in the row was the same. If it was, then we flag it as a neighbor, and if the previous row was the same, then we flag it as a vertical neighbor. And we ignore zeros in this step. So there were. Okay, so if a cell is the same as the previous column and column count ++, and the previous row was this, okay. Column count was greater or equal to 3, and then we flag horizontal neighbors for crashing. Else, if previous row count is greater or equal to 3, flag vertical neighbors for crashing. Yes, I think this makes sense. And then previous column equals cell. Okay, so flagging vertical neighbors for crashing, it means that we are going back. Okay. Yes, so yeah, maybe I'll make it as the coordinate type abstract with x int and y int, and then I could type coordinate set will be a list of coordinates, and then it doesn't really matter this much. Okay. So what we're going to do is we're going back row count times in rows. So we are going to go from for row for yeah, we could actually yeah, and actually the row count has to be greater or equal to 2, because we are only counting the neighbors, the other neighbors. So so I would say for we are flagging rows. So let me see. If row count is greater or equal to 2, then we start at the, I'm thinking of a name. Can somebody come up with a name? For can I just shadow it? Row to delete equals y row to delete row to crush. Equals y row to crush is greater. So let's say we start in row number with the index of 3 and we want to delete 3 rows, then the neighbors would be start y equals y minus row count and y equals y yeah, basically it's just a range, so I just say I for I in the range of row count we are going up, so I is row to delete equals y row to delete is greater or equal to y minus row count row to delete minus minus coordinates equals coordinate of x and row to delete to crush equals append to crush coordinates, and then row count has to be zeroed. Or maybe we're going to do the same here. So if column count is greater or equal to 3, which means there are at least 3 neighbors with the same value, then for column to delete is equal to x column to delete is greater or equal to x minus column count column to delete minus minus I can just inline this. Yep. That would be y column to delete and y and column count equals 0. Okay, and now we are doing the crushing, and this is going to be running in a loop. Okay. Okay, and now I'm going to and it seems I never needed this, so mark for crushing, and then there is going to be a second step, and this is going to be for coordinates into crush and board chords y chords x equals 0, and now with the gravity part we are going to going in columns, I think. Okay, for x in range of n, we're going to be doing the same for each column. And then we are going to go up for y equals m minus 1. How do I do the gravity step? I don't even know. We go up. We go up and we swap. Let me see. I go from the bottom, and that is the m minus 1, and m is the height of the board. If I find 0, I'm going to be looking for the next element that is not 0. Y equals n minus 0, y is greater or equal to 0, y minus minus. So we are going to go for every single element in here. So this cell is board at y and x. If cell equals 0, it means we need to search for the next row that actually has a value in this column, and this means I think I'm going to make the text bigger. Okay, so if a cell is 0, then search for the next non-zero row. And if there are none, go to the next column. Okay, so if there is one, swap. Okay, so the next non-zero would be last non-zero would be okay, so I search for the next row, so I'll just go up and see. So for next row equals y plus 1 y is greater or equal than y minus 1 y, because we're going up and we're going up and the y coordinate is decrementing. So y is greater or equal to 0, y minus minus other cell equals board next row at x if other cell is not 0, then board yx equals other cell board next row and x next row equals 0, and with break. And if we cannot find, okay, so we found the next non-zero row. If there are none, go to next column. So continue rows, okay. And if there are none, continue columns and return board. Okay, this looks like it could work, and it probably just doesn't. And smaller. Layout has to be default and run. Undefined Candy Crush solution go. Okay, let's see. Unexpected comma in a structure, possibly missing semicolon or new line or, okay. Cannot use cards arranged to crash. To crash, declared and not used. Okay. Okay, so it doesn't work at all. But let me see. Okay, so this is the first example. The first example is from here, and we are getting 3, 7, and this is x and y, so 3, 7. What would be Okay, I think I may need another break, and maybe I'll just go to sleep, because no, I'll take a break, maybe a longer one. I need to try it in NeoVim. So problems list. I'm searching for Candy Crush, and I'm going to copy everything, and they didn't get copied. Let's see, maybe if I disable Vim mappings, then I can copy it. Okay, yes. And here let's run. Wrong answer, okay. Okay, so now let me see. Firstly, I start with to crash. It's empty. It's an empty list of structs. I'm going from every row. Do I need the row? I probably do not. I may need it, okay. Previous column. So we restart the previous column for every row. We restart row count. Okay, maybe restarting row count for every row is incorrect. We actually want the row count to be the same here, and run it. Okay, so it seems like we may be getting the... No, this doesn't make sense. We may get okay, so it says $876. Okay, so apparently it only finds vertical neighbors, and probably incorrectly. So You know what, guys? It's 1:30. I'll continue grinding tomorrow. I'll keep this open so we know where I stopped, and I will see you tomorrow. Goodbye.